Hello, everyone. Welcome. Do you know what time it is? Yep, it's our very first math class. And so right now, what you're going to do is go ahead and share the link, share the link in your church groups, share the link in your class groups, share the link with your teacher, the teacher can share with the students. It is math time and we are ready to learn and to have fun. All right, so for those of you who are afraid of mathematics, welcome, I love you. All right, so today we're gonna be doing matrices. We're gonna be looking at the topic matrices. We're gonna be looking at some basics. We're gonna look at CSEC questions, and CSEC questions will be a feature for all our math classes. All right, so here we go. Grab your book, grab your pen, grab your pencil, get your calculator, whatever you think you need for math class, get all of them and come. And once you are back, I give you 5 seconds, 10 seconds. All right, once you are back and you are ready, sit down good and just type in the chat, ready. All right, so let me know that you are ready. Again, go ahead and share the link, Let us begin. All right, so I find that students sometimes try to run away from this topic. So we're gonna face it today. All right, what exactly does matrices involve? What exactly is a matrix? The singular form of matrices. What exactly is a matrix? All right, so we're gonna look at that. How does a matrix look and stuff like that. All right, so a matrix is really a set of numbers that are arranged rectangularly, all right, in terms of rows and columns. And if you don't know what a row look like or what a column looks like, you are going to, there is just a little reference picture there on this side. All right, so rows go across left to right horizontally, and our columns run up, down, all right, vertically. So we should also note that the numbers that are going to be in our matrices, these are called elements of the matrix. All right, easy. And we will refer to that sometime later. All right, so I took this set of this information. All right, so this set of statistics from a website. All right, some previous championship that had taken place. All right, football. So we have the football teams on the left, and what exactly do these numbers represent? All right, so let's talk about the headings first. There is the number of matches played, the number of matches won. Good, there we go. Number of matches played, number of matches won, drawn, lost, the number of goals for the team, against the team, and goal difference. All right, fine. So I have circled some numbers. Let's look at 39. What exactly does 39 represent? All right, so 39 clearly is going to be the number of goals that were made against, so we come down and we go across, against the Derby County. All right, and if we look at 10, that's going to be the number of games that the Watford team lost. And that 19 represents the number of games won by the Brentford team. So if I were to ask you, how many games did Norwich City draw? Then you're just going to go Norwich City, draws, and we are going to get to 8. All right, so this set of numbers, can be written as a matrix. And how exactly do we write a matrix? It's going to be simply looking like this. All right, so it's pretty much all the numbers arranged, rows, columns, with curved brackets or squared brackets around them. All right, so what if I were to write a matrix that represents the number of games, let me use a different ink, the number of games won, drawn, and lost for, let's say, Derby County, Middlesbrough, and Norwich. All right, so our matrix would look something like this, whether with curved brackets or square brackets. All right, so we're gonna have wins for Derby County, that's 19, draws 9, and losses 8. All right, for Middlesbrough, the numbers are gonna look like 19, 9, 8. Norwich is going to be 19, 8, 9. All right, so you get the point. All right, a matrix can be used to represent something like this. All right, so we are going to take our time and move on. All right, how do we name a matrix? And that's pretty simple. The answer is using capital letters. You'll generally see a matrix being named or represented using a capital letter. All right, so what do I mean? It's just simply this. We just say matrix A is equal to, say those are the elements, 1, 2, 3, 4. Matrix C equals 7, 10, 5, 2, etc. All right, and we can have a different number of elements inside the matrix, of course. All right, so how do we name our matrix? That's going to be with a capital letter generally. All right, and so we are going to move on to the next page. So we're going to talk about the order of the matrix. Now, we just said that the matrix can have pretty much not necessarily just looking like this, not just 4 elements, but it can have 8, can have 16. All right, fine. So it's going to be a rectangular looking thingy, right? But to be more specific, we're going to look at what exactly do I mean when I say what is the order of the matrix. Now, the order is the same thing as the dimension. So rectangular, if you think about a rectangle, you think about the dimensions, you think length and width. All right, fine. And if we think about the order of the matrix now, it's pretty much exploring how many rows do we have in our matrix and how many columns do we have in our matrix. All right, so go ahead and erase this. How many rows, how many columns? All right, fine. And as I said, it is referred to as the dimension of the matrix. All right, now, so let's take a look at this example we had first. What would be the order of the matrix? How exactly would we write that? It's going to be pretty much this. Ask yourself how many rows are in the matrix. And remember, we said rows run across. So this would be our first row, row 1. And this would be row 2. How many rows are in our matrix? That would be 2. Now, how many columns are in our matrix? All right, here's our first column. Here's our second column. That would be 2 columns. And so the order of this matrix would be written as 2 by 3. And why do we write it like that? All right, so let's move to C. And you can run ahead of me and start identifying what the order of this matrix would be. All right, how many rows are in matrix C? 1 row, 2 rows. All right, how many columns are there? 1, 2, 3, 4. And so the order of our matrix would be 2 by 4. All right, you can take your little 5 seconds, 10 seconds to get that off. All right, so that's pretty much the basics of how we write the order of a matrix. All righty, so here we go. When you talk about the address of an element, and remember we said that elements are the numbers that actually make up the matrix. All right, all the numbers that are a part of the matrix, those are elements. No question, simple question, nothing odd. Where is your address? Yep, that is where you live, which part you reside. And so it's similar with for the elements. So the address of an element, as you can see, is given by listing the row number and the column number. So if I have, let's say, matrix E, looking like this, 1, 1, 4, 2, 3, 6. And I say, I want to know what is the address of the element 2. It's simply, as it says here, the row number, then the column number. So we have 2 being in what row? That's going to be row 2. And we go straight across to represent, to identify what is the row. All right, so that would be row 2. And then we have what column is the element in. That's going to be the first column, as we can see. And so the address for the element 2 would be row 2 and column 1. All right, and you can also write out the word. So row 2 and column 1, that would be the address of the element. Let's just do one more. What would be the address of the 4? The address of 4 would be, what row is that? The first row. All right, so that would be row 1. And then our column would be not the first, not the second, but the third column. All right, and I am going to let you do one by yourself. All right, what is the address of the 3? What is the address of 3? Go ahead, feel free to type it in the chat. All right, go ahead and do that one before me. What is the address of the 3? All right, good. Now, if you typed or said or wrote in your books, if you wrote row 2, column 2, then you would be correct. All right, so the address for the 3 would be row 2, column 2. All right, good. And I know you're doing good so far. All right, so there are different types of matrices. And the first one we're going to look at is what is called a row matrix. And it's pretty simple. It's just a matrix that has one row. It can look like this. That's a matrix. It can look like this. That's what, 5 elements. That the second matrix I wrote here has 5 columns. The first one has 2 columns. It doesn't matter how many columns are there, as long as there is one row. This is known as a row matrix. And you can guess what's coming up next. A column matrix, which is a matrix that has just one column, same way. All right, so while you take the example off, you can just make up your own column matrix. All right, so this is gonna be, let's say 2, 1, 4. Done. All right, or 1, 1, or let me not do this one this big. 3. This matrix here has, let me just name them so I can refer to them. Matrix F has 1 row and 1 column. All right, so yes, a matrix doesn't have to have like more than 1 element. It can have 1 element. All right, so here we go. All right, another type of matrix is what we call the square matrix. If you know anything about a square, go ahead and tell me in the chat. What do you know about a square? As you hear square, what the first thing jump to your mind? All right, so what exactly do you know about a square? First thing that pops at you is that the length of all 4 sides, this square is really crooked. The length of all 4 sides is gonna be the same. So similarly with the square matrix, the matrix is gonna have the same number of rows and the same number of columns. Easy, all right? And then we have what is called the zero matrix, and it's simply the fact that the elements, all of them, are zeros. Doesn't matter how many rows, how many columns, all the elements are zeros. As I hear zero matrix, that's the first thing you should think of. All right. And the identity matrix is a special kind of matrix, very important one too. All right, so you may have heard terms like additive identity and multiplicative identity for regular numbers, right, integers. And for the matrix, the identity matrix is a matrix, just like how you have 2 times 1 equals 2. And 1 would be the multiplicative identity of any number, because once you multiply a number times 1, you get 2. Similarly with a matrix, with matrices, there is a matrix that if you multiply another matrix by it, you will get back the original matrix. So let's say the matrix is 1, 2, 3, 4. there is a matrix that when you multiply any other matrix by it, you get back the original matrix. But we will get to that in another class, all right? And the identity matrix looks like this. And that is the identity matrix for a 2 by 2 matrix, all right? So the identity matrix for a 3 by 3 matrix would be, it would look something like this. All right, so as the definition says, all the diagonal elements are equal to 1. And as soon as you hear diagonal, you're supposed to think lines running like that or like this. The diagonal that we're referring to right now is called the leading diagonal, and it starts from the top left corner and goes straight to the bottom right. That's what we call the leading diagonal. So all the elements of the leading diagonal are equal to 1. Every other element is a 0. All right. So at this point, we're going to see if you got it. All right, so I have some matrices there. All right, and the first question is, get ready with your quick fingers. The first question is, how many columns are in matrix B? How many columns are in matrix B? Dun, 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 dun. How many columns are in matrix B? And remember, our columns go down, up, down. All right, so our columns run vertically. And so we're going to look at matrix B. How many columns are there? 1, 2. All right, so if you said 2, you can go ahead and pat yourself on the shoulder. All right, so put one little sticky in your book if you got that, and big up yourself if you got it in the chat. All right, and if you think that you weren't brave enough to post in the chat before, you realize that the question is easy. So let's go. All right, how about what is the order of matrix C? What is the order of matrix C? Take your 5 seconds to go ahead and take a chance to post it in the chat. What is the order of matrix C? All right. And now I'm going to reveal. All right, so the order of the matrix C, how many rows are there? 1, 2, 3 rows. We're going to write that down first, times how many columns are there? That's going to be just 1 column. All right, so the order of matrix C is going to be 3 by 1. All right, moving on to our next question. So we're using the same matrices. What kind of matrix is matrix D? What kind of matrix is matrix D? What kind of matrix is that? Go ahead and share your answer. What matrix is D? What kind of matrix? All right, and drum roll, drum roll, drum roll. We have more than one possible answers. So if you said it is an identity matrix, that is correct. And if you also said it is a square matrix, that is correct. It's an identity matrix because all the elements of the leading diagonal are 1, and it is a square matrix because the same number of rows are there with the same number of columns. All right. And we have another. What is the address of -6 in matrix B? We have matrix B. What is the address of -6? What is the address? All right, take your time. And if you finish before the rest of us, go ahead again and just share the link so that others can join the class. All right, ready? So we have the address being which part the -6 live. Where does him reside? All right, so this is gonna be, what row is it in? So that's gonna be, this is row 1. Row 2, remember rows run across, just in case you're just joining us. Rows run across left to right. And then we have row 3. This is in row 3. So the address of number 6 is gonna be row 3. And the address is incomplete, so we have to tell what column is it in as well. There are 2 columns and it is in column 1. All right, so if you get that right, yourself a sticky. All right, and we have another one. All right, which element is in row 2, column 2 in the matrix D? We have the matrix D. Which element is in row 2, column 2? Testing, testing one. All right, ready? I hope you already get it. All right, row 2, you just draw your hand along row 2. Use your pencil. All right, along row 2. And then column 2, and you can just wherever they intersect, that's definitely where the element, that's definitely the element that we're looking for. All right, so yeah, the element in row 2, column 2 in matrix D would be 1. All right, I see we're getting there. All right, so there is now a CXC question, and it says a superstore sells 3 models of cell phones. All right, model A costs $40 each, model B $55, and model C $120. All right, now we have a listing of the sales for the different weeks, for 2 weeks in June. All right, so for week 1, how many model A cell phones did they sell? That's going to be 2. If I ask you for week 2, how many model B cell phones are sold? That's going to be 6, etc. Just so you understand the information. All right, part 1 of the question says, write down a matrix of size 3 by 2. So that's the order of the matrix right there. We need to write down a 3 by 2 matrix that represents the sales for the 2 weeks. And that's pretty simple because you're pretty much writing down what's literally before you. All right, these are the sales. 2 of such one, 5 of the other one, 3 of the other one, 9 of that, 6 of that, 10 of that. All right, so you're pretty much just writing down the numbers only. All right, so our matrix is gonna look like this for part 1. All right, so we have 2, 5, 3. There's no model A for week 2, so we have 0, 6, 10. All right, so that's your answer for part 1. All right, so for those of you who are going to be typing in the chat, just so that you can comfortably write out the elements of the matrix, I'm going to allow you to just go row by row. All right, so if you want to share your answer with us, you can just write 2, 0. In your next line, you write 5, 6, 3, 10. All right, just go row by row. All right, so that's our 3 by 2 matrix. And when you're done, you check if you have the correct order. All right, 3 rows, 2 columns. Yes, okay, I'm good. All right, number 2 says, part 2 says, write down a matrix of size 1 by 3. So this matrix has 1 row and 3 columns, 1 row. What kind of matrix this we're talking about? It has just 1 row. That's a row matrix. All right, and we need to write down a 1 by 3 matrix that represents the cost of the different models of cell phones. Now they gave that to us, $40, $55, $120. All right, and so here we go. The matrix is gonna have 1 row and 3 columns. I'm making space for that. All right, and so the costs are gonna be 40, 55, 120. Done. So you read the question and you feel like it's $1 million question they might ask, but really and truly, first of all, when you see 1 mark, you know, it's pretty simple. All right, yep. So that's pretty much how we would solve that CXC question. All right, now matrices can be operated on. So we can add them, subtract them, multiply them, and we are going to look at all of those. But right now, we're just going to look at addition and subtraction of matrices. Pretty simple principle. And once you get that, then you should be fine. All right, so here we go. We have the matrix E, which is 5283. Let me just pause here to say that you can always come back later to probably make notes if I was moving too fast for you. All right, if I'm moving too fast for you, you can always come back to finish right. All right, so here we go. E is 5283, and the matrix C is going to be 1243. And we are asked to add E and C. All right. Now we know we have common sense. So what we're going to do right now is just to write down what exactly is E. All right, so that's going to be 5283 plus what is C, 1, 2, 4, 3. All right, and you don't even need to integrate 8 to guess and tell me how exactly you would add these. All right, so you're naturally, the human mind will tell you what to do. But anyway, we're gonna say it anyway. All right, so we are gonna be adding the elements of both matrices. How are we gonna do that exactly? All right, so I know you can tell me from the top of your head, I believe in you. All right, that we're gonna say we're adding 5 plus 1. We're also adding 2 plus 2. We're adding 8 plus 4. And we're adding 3 and 3. All right, so our final answer would have been, all right, 5 plus 1 gave us 6. 8 plus 4 gave us 12. 2 plus 2 will give us 4. 3 plus 3 will give us 6. All right, so that's the answer. What did we do exactly? All we did was add the corresponding elements, or the matching elements in the matrices. So that's which element has the same address, which element is in row 1, column 2 over here, which element is in row 1, column 2 in a matrix C as well. And you add those elements together. All right, fine. So you should be done writing while I'm talking. All right, so that's how we would add them. And subtraction, we're subtracting similarly. So we're going to be subtracting the corresponding elements in both matrices. All right. Here we go, here we go. And if you're not a CXC student, but you're tuned in and you're learning, you can go ahead and comment, got it. Comment learning. All right. So students, if you got it up to this point, you can go ahead and just say got it. It confirms if we learn. All right, so here we go. The next question says, and I'm going to be very shorthand here, just to show you that it's just a minor difference. All right, so it says we're doing E minus C. So that means it's that first matrix minus the other one, the reverse of what we would have done before. And so it means the element in matrix E that has the same address as the element in matrix C, we're going to subtract those. All right. And so to save us a little bit of time, I'm just going to remove the signs. All right. So we have 5 minus 1. Let me go ahead and erase these ticks. All right. So we have 5 subtracting 1. Similarly, we have 2 subtracting 2, and so on. 8 minus 4, 3 minus 3. All right, and so this is going to be 5 minus 1, that's going to be 4. 2 minus 2, 0. 8 minus 4, 4. 3 minus 3, 0. All right, so we are going to be moving right on. All right, so you realize that the whole concept of adding and subtracting matrices is basically, you're going to be successful depending on whether you know how to add and subtract regular numbers. And are you good with your positive and negative numbers? Because we're coming up on that next. All right, so give yourself a little revision, because the addition and subtraction, multiplication and division of positive and negative numbers, of integers or signed numbers, whatever you want to call them, those are integral for the rest of your math life. All right, so here we go. We are going to be adding these matrices. All right, so we go again similarly. All right, we're going to use the same concept, same principle. So we're adding 5 plus negative 8. And if you're a good math student, then you know you can put a bracket around your negative 8 just to separate your signs a bit there. All right, then we're also adding -7 plus -3. 4 plus 4. Then we also have 6 plus 0. All right, let me just clean this bracket up a bit. All right, great. 5 plus -8, whenever you're adding two numbers and the signs are different, you know that you're going to subtract 5 from 8, 3, and keep the sign of the larger number. You know that little jingle, that little gem you say. All right, and then we have 4 plus 4 giving us 8. Then we have -7 plus -3. Both signs are the same. And so you are going to add the numbers together, but keep the sign. All right, 6 plus 0 gives us 6. And that is our final answer. All right, so if you got it before me, give yourself an extra sticky. All right, so as you can see, adding and subtracting matrices is really no biggie. All right, and even when you get to multiplication, again, as I said, it's just gonna be principle, right? It's gonna be principle. Are you following the principle? Or are you just trying to follow a formula? All right, but anyway, I was just giving you time to write. So we're gonna move to almost our final example. I think this is the penultimate one. All right, so we have the matrix P being what you can see there, 5, -2, -3, -4, 7, 2. And T being 10, 16, 0, -4, 5, 2. Now, we are asked to find the value of T minus P. So you have to be very careful, all right? So you were given the matrix P first and then T, but you're asked to find T minus P. So be careful of the order, because since I know you all are good math students, then it means that I also know that we know that P minus T and T minus P is not the same thing. All right, so T minus P is going to be 10, 16, 0, -4, 2. All right, minus, and that's going to be P, which is 5, -2, -3, -4, 7, 2. All right, we're subtracting those. So we can go ahead, please. I only am doing this because I don't have much space on the screen, but do not put two equal signs in the same sentence. Just go ahead down below and put your answer down below. All right, so here we go. But since I have the space on my right, I'm just going to use that up. All righty, so we have 10 subtracting 5. We have 16 subtracting -2. And I'm saying that slowly because sometimes you made the mistake of just skipping one of the subtraction signs and say, okay, 16 minus 2. All right, so it's 16. Let me just. All right, 16 minus -2. You are writing down everything. All right, and then we also have. That's the wrong ink. All right, so now we also have 0 subtracting -3. And we have -4 subtracting -4. In this corner here, we have 2 subtracting 2, and we have 5 subtracting 7. And right now, it's just going to come down to if you know how to add and subtract numbers properly, as I said before. All right, so we have 10 minus 5. Easy peasy. That's going to be 5. And let's move over to our right. 16 minus -2. Whenever two signs are directly beside each other, you can change them into 1. All right. And the same principle that you use for multiplying numbers with different signs or same signs, the same principle you use here. All right. So if the signs are the same, that's positive. They love each other. All right, so that's going to be 16 plus 2. And so this is going to be 18. And then we have 0 minus -3. Oh, again, the signs are the same. They love each other. That's positive. All right, 0 plus 3. We now read this as 0 plus 3, which gives us 3. And then we have -4 minus -4. They love each other. Positive. All right, so -4 plus 4 is going to give us 0. All right, and then we have 5 minus 7, which is not the same thing as 7 minus 5. All right, this is going to be -2. And we have 2 minus 2, which is going to be 0. And that would have been our answer for T minus P. All righty. So you can take your couple seconds to take that off. All right, guys, take a screenshot. All right. I should have been saying that from the started. All right, great. So after you take your 5 seconds, take your screenshot, which only takes a second. All right, so we are moving to one last example, and I promise it will not stress you out. All right, our final example. For this, we would be asked to add these matrices. All right, so let's take a look at these. We have the element in row 1, column 1 would be 5. The element in row 1, column 1 here would have been -1. All right, let's go. 5 plus -1. Column 1, but row 2. Column 1, row 2, we have -2 plus 9. And oops, we have nothing to match that element that's in row 3 in that second matrix. So what does that tell you? It is impossible to add them. So these two numbers cannot be added. These two matrices cannot be added because they, keyword, the dash, their dash are not the same. All right. So the order of the first matrix is not the same as the order of the second matrix. So if this is the 2 by 3 matrix, then the next matrix would have to be a 2 by 3 to be added to it. But this one is a 3 by 2 matrix. The first one would need to be a 3 by 2 matrix as well. They must have the same number of rows and the same number of columns for them to be added, for them to have corresponding elements in your all. All right, so here we go. This is our final question, which was not really one for us to work out because we know it's impossible. All right, so what do we say? I will see you in our next math class, and don't forget to revise. I promise next time you'll get homework. All right, so I will see you all. Don't forget to share the link to this video. You can always still share even if your friends were not able to join, and remind them that we have another episode that they can join us. So, and you do not miss it either. Ensure that you are back for us to do this again. All right, so it's goodbye from math class until next time.